Unit 5, Day 6 talks about factors and greatest common factors. After we're finished with today's lesson, we will be able to write the prime factorization of a number, and we will be able to find the GCF of monomials. A factor is a number that goes into another number evenly, so we have no remainder. So if we look at example 1, and we talk about the factors of 36, we want what numbers multiply together to get 36. So we have 1 times 36 is 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. If we list the factors of 37, the only things that multiply to get 37 is 1 and 37. So a prime number is a number with only two factors, one in itself. So when we listed the factors of 37, that is an example of a prime number. If we list prime numbers, we're going to start with 1. 2 is the only even prime number. 3 is prime. 5, 7, 11, 13, 17, 19, and we could continue on, but remember the definition is a number with only two factors, meaning 1 in itself is the only thing that multiply to get you that number. A composite number is a number with more than two factors. A prime factorization is a number that is expressed as a product of prime numbers. So let's talk more about prime factorization. So in example number 2, they ask us to find the prime factorization of 72. So they want us to find all the prime numbers that multiply together to get 72. And I'm going to show you two different methods. The first method I'm going to show you is upside down division. So we're going to start towards the bottom, and we're going to say 72 and put that underneath our division bar, and we're going to divide that by 2. So 72 is an even number, and I only want to divide by prime numbers. So these numbers out here need to be prime. So 72 divided by 2 is 36. I'm going to continue my upside down division. So a prime number that 36 is divisible by is 2. Another prime number that 36 is divisible by is, you could have chose the number 3. So 36 divisible by 3 is 12. Again, you could have used 2, and at the end you will still end up with the same answer. 12 is divisible by 2. Circle your prime number. 12 divided by 2 is 6. Continue. 3 is a prime number that 6 is divisible by. 6 divided by 3 is 2, and 2 is a prime number, so I'm going to circle it. All of the numbers circled on the left-hand side and on the top of our upside down division is what we call our prime factorization. So we're going to write all of those numbers in order. 2 times 2 times 2 times 3 times 3 will get us back to the number 72. So the prime factorization can then be simplified by saying 2 to the third power times 3 to the second power. The second method I'm going to show you is the factor tree method. So this time we're going to start with 72 towards the top, and we're going to ask ourselves what times what multiplies to equal 72. 8 times 9. Is 8 prime? No, so we continue with our tree. Is 9 prime? No, so we continue with our tree. So now let's look at the 8. What times what multiplies to get us 8? 2, and 4. Is 2 prime? Yes, so circle it. Is 4 prime? No, so continue with your tree. What times what is 4? 2 times 2 is 4. Is 2 prime? Yes. Is 2 prime? Yes, so please make sure you're circling your prime numbers. What times what is 9? 3 times 3. 3 is prime, so I circle it. 3 is prime, so I circle it. To write your prime factorization, you are going to write all of the prime numbers, which are the numbers you have circled. 2 times 2 times 2. Continue with the rest of your prime numbers. 3 times 3. If you multiply those all out, you would get back to 72. Simplify your prime factorization by writing 2 to the third power times 3 squared for the number 72. Let's try another example. If we want to write the prime factorization of 60. So I am going to use the factor tree method. 6 times 10 is 60. 6 is not prime, it's composite, so I continue. 2 is prime, 3 is prime, so I circle them. 2 times 5 is 10. 2 is prime, 5 is prime. To write my prime factorization, I'm going to write out all my circled numbers. 2 times 2 times 3 times 5. If I want to simplify that further, I can write 2 squared times 3 times 5 is the prime factorization of 60. The prime factorization of 140, if you use the upside down division, remember you want to use prime numbers on the outside, so 140 divided by 2 is 70. 70 divided by 2 is 35. 35 divided by 5, which is prime, is 7, and 7 is also prime. So the prime factorization of 140 is 2 times 5 times 7, which simplified can be written 2 squared times 5 times 7. So either method is okay. Whichever method you feel more comfortable with is the method I would like you to use. The next thing that we want to talk about is the greatest common factor, or the GCF. The GCF is the greatest number that is a factor of all the integers. So when we're looking at example 5, they say, what is the GCF, the greatest common factor between 12 and 30? So method number 1 is to list out factors of these two numbers. So when we list the factors of 12, remember factors are numbers that multiply together to get 12. So we have 1 times 12, 2 times 6, 3 times 4, and I know I have all the factors listed because there's nothing in between 3 and 4. If I list my factors of 30, I know I have 1 times 30, 2 times 15, 3 times 10, so you can see that our numbers are getting closer together, and if you list your factors this way, you won't make the mistake of missing any. 5 times 6. So then we want to look for the largest number that these have in common. So the largest number that 12 and 30 have in common is 6. So the greatest common factor between 12 and 30 is 6. Method number 2 is we can use upside down division. So if we list the factors of 12, I pick a prime number that 12 is divisible by. 12 divided by 2 is 6. I pick a prime number that 6 is divisible by. 3 times 2 is 6. I make sure all my prime numbers are circled. I then do my upside down division for 30. 30 divided by 2 is 15. excuse me. 15 is not prime, so I continue with my prime factorization. 15 divided by 5 is 3, and I circle both of those because they're prime. So you want to pick all the numbers that these have in common. So they both have a 2, so I'm going to put a 2. They both have a 3, so I'm going to put times 3, and the greatest common factor is the product of the prime factors they have in common. So the greatest common factor is 6. Again, either one of these methods will work. To find the greatest common factor between 54 and 24, you can also use prime factorization trees. 2 times 27 is 54. I circle 2 because it's prime. 3 times 9 is 27. Circle 3 because it's prime. 3 times 3 is 9. 2 times 12 is 24. Circle the prime number, make the tree on your number that's not prime. 2 times 6 is 12. 2 times 3 is 6. Again, you're going to take the numbers that they have in common, so they both have a 2, and multiply them together. They both have a 3, and they have nothing else in common. Multiply 2 times 3, and the GCF between 54 and 24 is 6. Remember, the factor tree method is just another method you can use. If you want to list out your factors, you can use that method, or you can use upside down division. So 45 and 24. If I use upside down division, I have 5 times 9 is 45. 3, 9 divided by 3 is 3, and I have all the prime factors of 45. 24 is divisible by 2, which is prime. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Make sure all your prime numbers are factored. You're going to take the numbers they have in common. They both have a 3. 45 does not have a 2. 24 does not have a 3 or a 5. So 3 is the greatest common factor between 45 and 24. If we continue with 75 and 16, 75 is 15 times 5. 5 is prime, 15 is not. 3 times 5 is 15. 3 is prime, so I circle it. 5 is prime, so I circle it. 16 is divisible by 2. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4. Again, you're looking for the numbers they have in common. 75 and 16, there are no numbers in common, so there is no greatest common factor between these two. 40 and 84, again, please use the method that works for you. 4 times 10 is 40, neither are prime, so you're going to continue with your trees. 2 times 2 is 4. 2 times 5 is 10. 84 is divisible by 21. 4 and 21. Neither one of these are prime, so you continue. 2 times 2 is 4. 7 times 3 is 21. What do they have in common? They have a 2. They have another 2. And they have nothing else in common. Multiply those together, so your GCF is 4. When you are trying to find the GCF and you have variables involved, you're going to look at your whole numbers the same way. 3 times 8 is 24. 2 times 4, 2 and 2. 2 times 10 is 20. 2 times 5 is 10, and then you're going to look for how many x's they have in common. So first look at your numbers. They both have a 2. They have another 2 in common. they have an x, they have another x, so the greatest common factor is 4x squared. If we look at 100a to the 7th and 90a to the 4th, 25 and 4, 5 and 5, 2 and 2, 90 is 9 times 10, 3 times 3, 2 times 5. List out your A's. They have a 5 in common, they have a 2 in common, they have an A, another A, another A, and a 4th A in common, so the greatest common factor is 10A to the 4th power. You can now complete your day 6 worksheet.